Hey there, science fans! Today, we're diving into the exciting world of chemical reactions. What are they? Well, they're like magic shows happening right in front of us. A chemical reaction is when substances change and become new substances with different properties. Think about baking a cake. You mix flour, sugar, eggs, and other ingredients. When you bake it, a chemical reaction happens. The ingredients change and you get a delicious cake with a totally new texture and taste. Chemical reactions are happening all around us, not just in the kitchen. They're in the air we breathe, the food we eat, and even inside our bodies. Plants use a chemical reaction called photosynthesis to make food from sunlight. Our bodies use chemical reactions to digest food and turn it into energy. Pretty cool, right? Chemical reactions are essential to life itself, and understanding them helps us understand how the world works. So let's put on our scientist hats and explore the fascinating world of chemical reactions together. Now that we know what a chemical reaction is, let's talk about the stars of the show, reactants and products. Think of reactants as the ingredients in our chemical recipe. They are the starting materials in a chemical reaction. Products, on the other hand, are like the final dish we get after the reaction is complete. They are the new substances formed during the reaction. Let's go back to our cake example. The flour, sugar, eggs, and other ingredients are our reactants. They are what we start with. After baking, the delicious cake we get is the product. It's what we end up with after the chemical reaction. In a chemical reaction, the atoms in the reactants rearrange themselves to form the products. It's like taking apart a Lego structure and building a new one with the same blocks. The total number of atoms stays the same, but they are arranged differently, resulting in new substances with different properties. Scientists use chemical equations to represent chemical reactions in a shorthand way. It's like a secret code that tells us what's happening. A chemical equation shows the chemical formulas of the reactants and products involved in a reaction. But here's the catch: we need to make sure the equation is balanced. What does it mean to balance a chemical equation? Well, remember how atoms are rearranged in a chemical reaction, but the total number stays the same? Balancing a chemical equation means making sure we have the same number of each type of atom on both sides of the equation. It's like making sure we have the same number of Lego blocks before and after building something new. To balance a chemical equation, we use coefficients. Coefficients are numbers we put in front of the chemical formulas to adjust the number of molecules or atoms involved. It's like adjusting the recipe to make sure we have enough of each ingredient. Balancing chemical equations might seem tricky at first, but it's like solving a puzzle. And once we get the hang of it, it helps us understand the exact proportions of reactants and products involved in a chemical reaction. On your way to school. Catalysts are essential in many industrial processes, like making plastics, fertilizers, and medicines. They are also crucial in our bodies, where enzymes act as catalysts to speed up biochemical reactions necessary for life. Section 5. Reaction rates, temperature, and other factors. We've seen how catalysts can speed up chemical reactions, but other factors can also affect how fast or slow a reaction proceeds. One of the most important factors is temperature. Think about making popcorn. When you heat the kernels, the reaction that makes them pop happens much faster. That's because heat provides more energy to the molecules, making them move faster and collide more frequently. The more collisions, the faster the reaction. Besides temperature, other factors can also influence reaction rates. Concentration, pressure, surface area, light, and pH can all play a role. For example, increasing the concentration of reactants means there are more particles available to react, leading to a faster reaction. Similarly, increasing the surface area of a solid reactant exposes more of its particles to the other reactants, speeding up the reaction. Understanding how these factors affect reaction rates is crucial in many areas, from controlling industrial processes to developing new medicines.